Hello and welcome to 9-5 Part 2. Today we're going to begin with Example 4. And Example 4 wants us to find the sine and the cosine of a 45-degree angle. So if we sketch a right triangle and we have something that looks like this, if this is 45 degrees, we also know that this is 45 degrees because that will give us our 45, 45, 90. So if I label this triangle A, B, C, and I want to find the sine of angle B, which is my 45-degree angle. Now, with this, remember on a 45, 45, 90 triangle, my side lengths are actually 1, 1, square root 2. So I know that sine is equal to opposite over hypotenuse. So the sine of 45 degrees is really equal to 1 over my hypotenuse, which is the square root of 2. And if I rationalize this, I get the square, or multiply it by the square root of 2 over 2. This is going to give me the square root of 2 over 2. Likewise, for the cosine of 45 degrees, so if I do the cosine, and we're going to still keep in mind looking at that angle B, so the cosine of 45 degrees is equal to the adjacent over the hypotenuse. And my adjacent side to angle B is a side length here of 1 over the hypotenuse, which is the square root of 2. Again, I'm going to rationalize that, and I end up getting the square root of 2 over 2. And that completes example 4. Now please pause the video and try to do this example on your own and then press play and see how you did. So for our extra example, we are looking to see which ratio is equal to the square root of 2 over 2. So I'm going to start out by looking at the sine of A. So when I look at A, I know that this is going to be 45 degrees based on my triangle over there. I also know that because I'm given this side length here of n, and so because I'm given the hypotenuse, I know that the hypotenuse is equal to the square root of 2. So, because remember with a 45, 45, 90, it goes 1, 1, square root 2. So I know that n square roots of 2 really equals 9, and n is my leg length, remember? So that tells me that n is really equal 9 divided by the square root of 2, or if I rationalize that, I really get 9 square roots of 2 over 2. So that's what each of these side lengths are. So 9 square roots of 2 over 2, and then this side length here is also 9 square roots of 2 over 2. So now when I go to find my sine, so the sine of A is equal to the opposite, which is 9 square roots of 2 over 2, over the hypotenuse, which is 9. So when I simplify this, I get the square root of 2 over 2. So I can go ahead and identify that sine A will give me the square root of 2 over 2. I'm also going to go through and do sine B. So sine B, if I'm looking at that, the opposite side length is 9 square roots of 2 over 2. And again, I'm going to divide that by 9. So this will give me the square root of 2 over 2. So I can say sine B out of that list. Then I'm going to look at the cosine of A. And the cosine of A is the adjacent side, which is 9 square roots of 2 over 2. My hypotenuse is still 9. So if I rationalize this, or simplify it, I get the square root of 2 over 2. So cosine A also works. I will do cosine of B. And cosine of B, when I look at my adjacent side, I have 9 square roots of 2 over 2. And I'm going to divide that by the hypotenuse, which is 9. So again, I get the square root of 2 over 2. So cosine B will work. And then my last one I have to look at is tan A and tan B. Well, tangent of A going to equal the adjacent, so that would be 9 square roots of 2 over 2, divided by the opposite, which is also 9 square roots of 2 over 2. And so when I divide those out, I'm going to get 1. And when I do tan B is going to be the same thing. I'm going to have 9 square roots of 2 over 2 divided by 2, which also equals 1. So you can see cosine A, cosine B, sine A, and sine B are all going to equal the square root of 2 over 2. Next, we have example 5. Example 5 says to find the sine and the cosine of a 30-degree angle. So your best bet is always going to be to start out with a sketch. So if I sketch a right triangle and I make this my 30-degree angle, this will be my 60. Remember your side lengths go 1, 2, square root 3. So when I go to find the sine of 30 degrees, I'm really looking at the opposite, which is 1, over the hypotenuse, which is 2. Okay, so sine of 30 degrees is equal to 1/2. And then the cosine of 30 is going to be the adjacent, or the square root of 3, divided by that hypotenuse, which is 2. Again, please pause the video, try this on your own, and then come back and double check your answer. So for this one, it says which ratios are equal to the square root of 3 over 2. So the first thing I'm going to do is I'm going to start out looking at the sine of m. So sine of m is equal to the opposite, which is the square root of 3 over the hypotenuse, which is 2. So that's going to give me this answer. So that works. The sine of p is equal to the opposite, which is 1 over the hypotenuse, which is 2. So that's not going to be a solution. The cosine of m is going to equal the adjacent, which would be 1 over the hypotenuse, which is 2. So that's not going to work. The cosine of p is going to equal the square root of 3 over 2. So that one will work. And then when we look at our tangent of m is going to be the opposite, which is the square root of 3 over the adjacent, which is 1. So this will simplify down to the square root of 3. And the tangent of p is going to be the opposite, which is 1 over the adjacent, which is the square root of 3. And this is going to give me the square root of 3 over 3 once I rationalize. And for our final example, we have example 6. This example says you are skiing on a mountain and you have to find the distance x from you to the base of the mountain. So I think I deleted out the sketch which goes with this. You have something that looks like this. We're told this is a 90-degree angle. This is going to be you standing right here. We're told that this is 21 degrees. Our distance here is x, and we know that we have an altitude of 1,200 feet. So if you have to find the distance x, we're really looking to find the hypotenuse of that triangle. So in order to find that, I look at the information that's been given, and I can see that with x, I have the hypotenuse, and then I also have an opposite side length from the angle that they gave me. So because I have an opposite side and a hypotenuse, this tells me that I'm going to be dealing with the sine function. So when I set this up, I know that the sine of 21 degrees is equal to my opposite side, which is 1,200 feet, over my hypotenuse, which is x. So now what I have to do is I have to get x by itself. It's in the denominator, so I'll be multiplying both sides by x to get it out of that denominator. That's going to cancel it out over here. And I'm left with x times the sine of 21 degrees is equal to 1,200 feet. To get x by itself now, I'm going to have to divide by the sine of 21. Please remember to put your calculator in radian mode if it's not already. And these are going to cancel, and now I'm going to be left with x is equal to 1,200 divided by the sine of 21 degrees. And if you type that into your calculator, you should get something around 3,348.5 feet. So that would be the length of your hypotenuse. That concludes the 9.5 video. Please let me know if you have any questions. Otherwise, have a great day.